Hey everyone, welcome to chapter 6. In this chapter, we're going to be talking about metabolism, and we're going to focus on what energy is and how energy is produced. And then we're going to get into, I'm just trying to get my color so that I have a good color, different metabolic reactions and how they work in our system. So what is energy? That's a great question. And so what energy is, it's the ability to work and bring about a change. And bring about change. That's an and sign. And so all cells need energy all the time. You need energy. When you are sleeping, you need energy to maintain your breathing, to maintain your heart, to maintain normal activities in your brain. All cells need constant energy. And where do you think these cells get their energy? So if we're talking about the earth, all cells are going to rely on one energy source, and that is the sun. So we all get our energy from the sun in some form or another. So there are two basic forms of energy. There is kinetic energy, which is the energy of motion. So when I think of this, I think of children running around. That's motion. If you play with like a pendulum toy, the balls hitting each other, that's motion. And then there's potential energy, that's stored up energy. And so when I think of this, I always think of like your coffee that you're sitting and holding right now, or your soda that you might be drinking. That's stored energy. It's potential energy. And so here's an example of both kinetic and potential energy. So climbing up the steps onto this diving board area, that is kinetic energy, and we're moving up towards potential energy. So once we get to the top, we now are just standing there, and that is potential energy waiting. So there's a buildup of energy, but it's waiting to go until the next person has jumped. So diving converts that potential energy back into kinetic energy. And then once we get into the water, we revert back to that potential energy while we're waiting to get back up onto the stairs. So that's kinetic and potential energy being seen. So energy can be described, or it can be discussed using two basic laws. The first law is, so both of these laws are the laws of thermodynamics, and the first law is the law of conservation of energy. And so this law states that energy cannot be just created or destroyed, but it can be changed from one form to another. So I can take energy and change it from potential to kinetic energy. I can't create energy or destroy it though, but I can convert it. And the second law states that energy cannot be changed from one form to another without the loss of usable energy. So no matter what, when you convert energy from one form to another, you lose energy. And the typical loss of energy is going to be found in the form of heat. Heat is a waste product of energy conversion. And so another way that we can describe the second law here is that every energy transformation makes the universe more disorganized. And what that means is entropy. So entropy is the amount of disorganization that we see in the universe. And so anytime we convert energy from one form to another, we increase the disorganization or the entropy of the environment. So let's look at what entropy really looks like. Oh, wait, first let's look at the law of thermodynamics. So here we're looking at solar energy. So this is the major energy source. This is our primary source of energy. RGY, sorry. There's a R there. You might not see it very well. So solar energy comes in, and we have these photosynthetic organisms like plants, which you're seeing here, but we also have bacteria, we have algae, all that are photosynthesizers. And these take the solar energy, so one form of energy, and they convert it to another form of energy in the form of carbohydrates. So they've just transformed energy using that first law of thermodynamics. So they transformed energy from one form to another. And as they did that, they lost energy in the form of heat. You can see that over here. So that's that second law. Loss of energy equals entropy. Okay. So we convert this energy, which is chemical energy, into the energy of motion. So chemical energy to the energy of motion is another form of energy transformation. And so as we do that, we again lose energy in the form of heat. So we're constantly transforming energy from one form to another, and we're constantly losing energy and increasing entropy. So every process that occurs increases entropy of the system. And so every process that occurs also requires an input of energy. And as I said in the beginning, the sunlight is our ultimate form of energy. So let's look at what entropy is. I knew I had these in here. So here you have a very organized room. An organized room is much more, well, organized, right? It has a lot of stored up energy in it. Whereas over here we have a less organized room, and there's not as much potential energy in it anymore. So a lot of energy, less energy. So we have increased the entropy of the environment and made the environment a little bit more stable. Again, here we have glucose. Glucose is a 6-carbon monosaccharide. It is the energy that our cells love, actually, to use. So glucose is broken down into carbon dioxide and water. Glucose is higher in energy, and it's more organized, so it's less stable. Over here, we have carbon dioxide and water, less organized, so more entropy and less energy. And one more example. Here we have the plasma membrane. Here we have hydrogen ions on one side of the membrane and none on the other. This is much more organized, a lot of potential energy, and less stable. Here we have hydrogen ions on both sides, less organized, less potential energy, but much more stable. So I'm going to stop on this slide, and in our next video, we'll talk about metabolism. Have a great day. Bye.